I want to start today with a discrepancy, and not just, a rounding error. I'm talking about a massive, just a terrifying gap between what was supposed to happen and what actually did.
Yeah.
We're looking at a number, 13,923.
That is a very specific and I'm guessing a very large number in this context.
It is 13,923 gallons. That's how much boric acid they pumped into a reactor coolant system.
Okay.
This was on October 4th, 2025.
Okay.
Now, here's the kicker. The calculated amount they actually needed. The target.
Yeah.
It was 2,798 gallons.
Whoa. So doing the quick math, that's almost 5 times the intended amount.
Exactly. A 497% overdose.
Wow.
A routine procedure that somehow spiraled into this massive 5x error. And honestly, looking at the source material we have, this Operator Training 2026 Module 2, it reads less like a technical manual and more like a psychological thriller.
It really does, because when you look at an event like this, the October 4th excessive boration event, it's easy to get hung up on the valves and the pumps. But the documents make it clear this wasn't really a failure of machinery. The pumps worked. The valves opened. This was a failure of the mind.
That's what grabbed me. It's all about distraction and high-stress environments and what happens when the people who are supposed to be watching the big picture
Decide to pick up a wrench.
Exactly. They get sucked into the small stuff.
It's a perfect case study in how tunnel vision can just completely dismantle a safety system that looks foolproof on paper.
So that's our mission for this deep dive. We're going to unpack how this happened. We'll look at the setup, the distraction, and this idea of the worker bee trap, which I think is going to resonate with you listening, even if you don't work in a nuclear plant.
Absolutely. The psychology here is universal.
So let's set the scene. It's October 4, 2025. What's the vibe in that control room before everything goes off the rails?
Tense. Very tense. The plant is undergoing a rapid downpower.
Okay, so this isn't a planned, leisurely shutdown.
No, not at all. This is happening because of an unisolable steam leak. It's on something called the Moisture Separator Reheater Drain Tank, or MSDT.
That just sounds loud and urgent.
It is. A steam leak like that forces your hand. You have to lower power, and you have to do it fast. So the crew is already reactive. They're already on their back foot.
The adrenaline is already up.
Exactly. The tempo is high from the very start.
And looking at our notes here on the staffing variable, the team wasn't exactly in their standard formation, were they?
No. And this is a critical piece of the puzzle, a precursor. They had a unit supervisor who was acting out of role. Meaning he was filling in as the reactor operator.
Okay, so let's unpack that. Because on the surface, that sounds like a good thing, right? A supervisor should be more qualified, if anything.
In theory, yes. They have the knowledge. They probably know the theory better than anyone. But think about it like the difference between coaching a sport and actually playing in the game. The supervisor, he's been in a management role. He isn't doing the hands-on, moment-to-moment stuff every single day. The source calls it a proficiency gap.
So the muscle memory might be a little rusty.
Precisely. There's a difference between currency, your license is active, and proficiency. You are practiced in the fast-paced, tactile parts of the job.
And here's the crazy part. The system knew this. It was a known risk.
Yes. They knew this guy might be a little rusty. And because it was a known risk, the protocol says you need more oversight.
Right. You put extra eyes on him, you watch him like a hawk.
You're supposed to. But ironically, it ended up leading to less oversight. But we'll get to why in a bit.
Okay, so we have this high-stress leak, a supervisor playing operator, and they need to add boron to the system to help lower power. That's the main job.
Correct. That is column A, the critical task. Reactivity management. It's safety critical. It needs unwavering focus.
You cannot mess this up.
You can't. You are literally controlling the nuclear reaction.
But then along comes column B.
The urgent distraction.
What was it? What popped up?
While all this is going on, a totally separate issue arises. The condensate storage tank, the CST, its levels start dropping.
A leak.
A leak in a manway on the condensate polishing skid.
Now, to a layperson, a leak always sounds bad. Is this column B problem as dangerous as the column A problem?
And that is the absolute core of the issue. The answer is a resounding no.
Okay.
The source material explicitly calls the CST leak a lower priority operational issue. It's messy, it's annoying, it's water on the floor that needs to be cleaned up. But compared to managing the reactor core,
It's a nuisance.
it's a nuisance, but it's a very shiny, very tangible nuisance.
And that's the trap, isn't it? Human brains are just wired to fix the leaking pipe we can see instead of worrying about the invisible chemistry we can't.
You've hit the nail on the head. It's something called task completion bias. We love problems we can see and touch and fix. The boration is just watching a number on a screen. It's abstract.
But a leak, you can grab a schematic, you can turn a valve, you can stop the water.
You get that little dopamine hit of solving something.
So the investigation's central insight is that the crew's attention was, and this is a quote, fatally diverted.
Fatally diverted.
Yeah.
They had a choice between the silent, critical task and the noisy, urgent one.
And they chose the noise.
Almost the entire room pivoted to that leak.
So let's get into the mechanics of the error itself.
Yeah.
I mean, you don't accidentally dump 11,000 extra gallons of acid just by blinking. This takes time.
A lot of time. And the primary error listed is a failure of what's called precise operator control.
Meaning?
Meaning when you start a process like this, you have to define the success criteria first. You don't just turn on the tap. You say, we will bulbrate until the tank reaches X or for Y number of minutes.
You define the stop before you start.
Exactly. It's like setting a timer on an oven. You don't just put the cake in and hope you remember it later.
But that's what they did.
That's exactly what they did. The source says the operation was started without those criteria. It was a set it and forget it failure.
They turned it on and then just looked away.
Essentially. They started the flow, and then their attention got completely pulled over to the CST leak. The assumption was, I'll just watch it out of the corner of my eye.
But the corner of their eye was glued to the wrong problem.
Right.
Let's visualize this. The tank of boric acid. What were the levels supposed to look like?
The source has a great graphic on this. They started at 100% full. The target stop level, where they should have shut it off, was around 80%.
Okay, so just skim the top 20% off the tank, a relatively small amount.
Small slice. Yes.
And where did they actually stop?
0%.
They emptied the tank.
The entire thing, the actual stop level was 0. The pump just kept running until it was sucking air.
How do you stand in a control room full of instruments and not see a tank level go from 80% to 0? That's not instant.
It takes minutes. And this is the most chilling detail for me. The system did its job. The machine tried to tell them.
It did. The alarms went off.
Oh, yes. The annunciators rang. The indicators on the board clearly showed the flow was still going. The tank level indicator was just dropping and dropping and dropping right in front of them. It was not a stealth failure,
Right.
but attention diverted. The investigation lists unheard alarms as a major factor. And it's not that the sound didn't happen, it's that their brains filtered it out.
They normalized it.
Yes. Think about when you're driving in a really heavy rainstorm, you're lost, you're trying to find an address. What's the first thing you do?
You turn the radio down.
You turn the radio down so you can see better.
Right.
Your brain has limited bandwidth. And when you are hyper-focused on one problem, like the CST leak, your brain starts to treat everything else as irrelevant data. Those alarms became background noise.
So they literally turned their backs on the main board to look at the other problem.
That's right. They didn't hear the alarm because their brains had already decided it wasn't important.
It's inattentional blindness. That's wild. Which brings us to the collapse of the safety net. Because, okay, the operator's distracted, but where was the leadership?
Where was the oversight?
Yeah. The shift manager, the shift technical advisor, the STA? You said earlier they were supposed to be watching extra closely.
That was the plan. Their whole job is to maintain the big picture. They're the last line of defense. They're supposed to stand back, arms crossed, and watch the whole room.
The conductor, not the musicians.
A perfect analogy. They are not supposed to touch the controls. They spot the errors before they happen. But in this case, the conductor dropped the baton.
And jumped into the orchestra pit.
He did. The report calls it an abdication of duty. The leadership got personally involved in the distraction. They became worker bees.
So instead of overseeing the whole operation,
they were over at the CST panel, looking at schematics, troubleshooting the leak. They went from strategic oversight to playing tuba.
So literally no one was watching this store.
The control room had zero strategic oversight. Everyone, from the top down, was working on the small problem.
And the big one just ran wild. It's fascinating because it feels good to help, right? To solve a tangible problem. I can see the temptation.
We call it the seduction of the wrench. For a manager, it's satisfying. Feels like you're helping the team, rolling up your sleeves. But in a high-stakes environment, it's a fatal instinct.
If the leader is sweeping the floor, no one's watching the fire.
That's it. And that brings us to the root cause they identified, tunnel vision.
They zoomed in when they should have zoomed out?
Exactly.
Yeah.
And the source uses this fantastic analogy to make it clear, the traffic analogy.
Oh, I love this. Walk us through it.
So imagine a busy intersection during a bad storm. The traffic lights are out. It's total chaos.
Right.
You have police officers assigned to direct traffic. Their only job is to stand in the middle and keep cars from crashing. That's the reactivity control.
High stakes?
Very. But then a tree branch falls and there's some debris in one of the lanes. That's the CST leak.
Okay, a problem, but a smaller one.
Right. And instead of directing traffic, the police officers abandon their posts in the middle of the intersection to go over and sweep the debris out of that one lane.
So the debris gets cleared.
The debris gets cleared. They fix the problem. They probably felt great about it. Good job, team.
But behind them.
A major pileup occurs because no one was managing the real risk. That pileup is the 5X aberration overdose.
That is such a powerful image.
Yeah.
You can just see them high-fiving over the cleared branch while cars are crashing everywhere.
And that is effectively what happened in that control room. They solved the leak, but they lost the plant.
So what comes out of this? I mean, an event this big has to trigger some major changes. The source calls it an operational reset.
It does, and the goal was to move from being reactive to proactive. They didn't just say, be more careful. Hope is not a strategy.
Right.
They put in real structural changes. The first one deals with that proficiency gap we mentioned.
The rusty operator?
Exactly. Corrective action 1. They brought in mandatory self-check simulator sessions specifically designed to replicate high-stress transients.
So they're practicing for chaos.
They're building muscle memory for stress. So if a supervisor has to step in again, they've recently practiced that exact high-pressure scenario.
That makes a lot of sense.
Yeah.
What about the worker bee problem? How do you train a leader to not help?
That's corrective action 2. Reestablishing inviolable oversight.
Inviolable. That's a strong word.
It has to be. It means it cannot be broken. They created a last line of defense champion on each shift. Basically, one person whose only job is to remind everyone else to stay in their lanes.
A designated driver for distraction.
Pretty much.
Right.
And they're adding targeted coaching for shift managers on situational awareness, teaching them how to resist that urge to jump in.
Yeah. And there's a third action about planning ahead.
Yes, integrated risk. They're putting the shift managers into the T-week or weekly work planning process.
So they're in the room before the week even starts.
Right. The idea is to have them challenge the risk before it happens. To look at a plan and say, wait a minute, if we do this and this other thing happens, are we vulnerable? Do we have a rusty operator on that shift?
Trying to predict the storm before you're standing in the middle of the intersection.
If that's the goal, if you see the trap beforehand, you're much less likely to fall into it.
You know, as we wrap this up, the source boils it down to 3 inescapable lessons. And I feel like they apply to so much more than a power plant.
I agree completely. The first is that precision is paramount.
You have to know what success looks like before you even start. You can't just do the thing.
Define the finish line before you start running. The second, attention is a finite resource.
That one sticks with me. You only have so much brain power. If you spend it on the distraction, you've got nothing left for what matters.
You have to budget your attention like you budget money.
And the third.
Oversight is the last defense. Leaders cannot become worker bees. If you're in charge of the big picture, you have to force yourself to step back.
Especially when everything in you wants to dive in and help.
It's about defining your contribution. Sometimes the most valuable thing a leader can do is stand perfectly still and watch.
Well, there you have it. The anatomy of a 13,000-gallon mistake. From a steam leak to a shiny distraction to a room full of smart people all watching the wrong needle.
A very expensive lesson in human psychology.
So here's the thought I want to leave you with. We all have our own control rooms. It could be leading a project, managing a team, or just getting through a chaotic day. When the alarms start ringing, ask yourself, are you directing the traffic? Or are you just sweeping debris in the corner while the cars pile up behind you?
That's the question.
Thanks for listening to this deep dive. Stay safe, watch your gauges, and we'll catch you on the next one.